How do we test deploying Azure ML models before sending them into production? I'll show you how to try things out locally in this video. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Azure ML allows you to deploy trained models to hosted services in Azure Container Instances and Azure Kubernetes Service. But it turns out there is another way to deploy these models. You can deploy them locally as Docker containers. Let's take a moment and talk about some of the reasons why we might want to do this. First, deployment to an Azure Container Instance can be slow, especially if you followed along with my prior videos and spun up an inexpensive container instance with a fraction of a CPU core and half a gig of RAM. It can take a good 10 minutes or so for the deployment to complete and validate, depending on how many packages you're installing. So if you did make any kind of mistake or want to develop iteratively, that's a lot of time cooling your heels. And let's be honest, we're going to make mistakes with Azure ML because there's a lot of semi-hidden ceremony, and the Azure ML examples repo can only do so much to enlighten us. Azure ML is complicated when you're working on code-first model development and deployment, so an iterative approach to development is the key way to retain your sanity, assuming you had any to begin with. Now, here's the kicker. Azure ML errors don't always get logged appropriately. One of the more frustrating things is waiting 10 to 15 minutes for a deployment to complete, and you get the dreaded failed deployment message. So you say, okay, that's fine, it failed. Let me go to the logs and find out exactly why it failed so I can correct this. And then you open up the logs tab, and there's nothing there. Even checking out the logs in Azure Container Instance gets you nowhere because the container was already killed or removed by the time you get an alert that all is not well. The solution? Deploy it locally, see what the error is, because then you'll be able to collect all of the error messages and logs. You can also debug your scoring script against local deployments using Visual Studio Code. It's not something I really do very often, and it is currently in public preview rather than GA, but it can be helpful if you have a complicated scoring script. If all of this sounds interesting to you, let's talk about what you need. First, you're going to need some software installed. Specifically, you will need Docker, the Azure CLI, and the Azure CLI ML extension v2. For local debugging, you'll need Visual Studio Code, though as a quick note, I'm not going to cover local debugging in this video. And because we're going to create these deployments with Python rather than PowerShell, you will need the Azure ML Python SDK v2. But if you watched the videos on Code First Azure ML development, you've got all this stuff installed already, so you're good to go. Second, you can only create online deployments locally. Batch endpoints only run in Azure, so there's no option to run them locally. That's why we didn't touch on this topic during the Code First series, as we created a batch deployment and endpoint combination. Third, you cannot create traffic rules or handle authentication for local deployments. In other words, you won't need to send in any sort of bearer token and cannot control who has access to the endpoint when you've deployed it locally. Now, as we'll see, Azure ML exposes arbitrary high number ports for local deployments, so if you have a reasonable firewall configuration, you're not exposing yourself to risk here. But this also means you cannot test these security things locally. You can only test them after you deploy to Azure. Speaking of deployments, the fourth consideration is that we can only create one deployment per endpoint. I don't think that's a big deal for testing, so I consider it more of a, hey, just to let you know, rather than a proper limitation. But the fifth and final item on my list is absolutely a limitation. You can only use local model files. You cannot read from Azure ML registry. You can certainly try, but you'll get errors in your scoring script, as I'll show you. So now, let's go to the demo and see the magic. Here we are in Visual Studio Code, looking at a repository. I'll link to the location of this GitHub repo in the description below. In it, there's a README file containing instructions on what to do. but we don't need instructions here. We'll intuit our way through it, as I'm sure that'll work swimmingly. Also, I'm going to purposefully show you several common problems before we get to the correct solution. That way, you'll get to see some of the issues you're likely to run into at some point or another, and learn how I actually performed the troubleshooting I needed to do to make the prior video on getting Azure ML and Power BI to play nice with one another. Let's look at what we've got here in this folder. Inside the source menu, we have another folder, trained_models. This is the Chicago parking tickets code first model that I downloaded for the prior video. For our testing, we only need the model pickle file, but I did bring down all of the assets because I did need those to upload to the other Azure ML model registry. The next file I want to call out is deployment.py. We import a few things in the first 9 lines, and then I have a place where you can put subscription ID, resource group, and workspace. That's because I don't have a .azureml folder with a config.json file in here, and this deployment script is more for testing than something I'd check into a company's code repository. After that, I create the ML client, which assumes I've already logged into the AZ CLI. If you haven't, it will prompt you to do so using AZ login. Lines 25 through 31 define an endpoint, which I'll call Web Service Local Test. This will be a managed online endpoint. Then on line 32, we create or update that endpoint. Importantly, there is a Boolean flag, local equals true. This is how we tell Azure ML that we want the endpoint running locally rather than in Azure. Line 34 grabs the trained model from the trained models folder. We'll need that model for the deployment. Another thing we need for a deployment is an environment. That is a base container image that we'll want to start with, plus a conda file that we'll use to install whatever packages we need for inference. You can see that the base model is the Azure ML scikit-learn package that we used for our Azure deployment. I will tell you up front, this will fail because we cannot have a remote Azure ML curated environment for a local deployment. Still, I'd like to show you the error that we get when we try it so you know what to do if you ever see this error in your own operations. Lines 43 through 56 define the managed online deployment that we'll use. I'll call it Web Service Local Test Deployment. And it needs several things. We need to define the endpoint, the model we're going to use, and the environment we want to build off of. In addition, I need to tell it where to find the scoring script that we will want to use. My local scoring script is called score_model_local.py, and we'll check it out in a moment. The final lines, referencing instance type and count, aren't actually relevant here because we're deploying locally. They're in there because I could use a very similar deployment call to push this into Azure where they are needed. Finally, line 57 kicks off the deployment. Before we look at the scoring script, let's kick this off and see what we get. I have here a Windows terminal with 2 tabs pre-configured. The first tab is Python and the second one is PowerShell. In the Python tab, I've already set the variables for subscription ID, resource group, and workspace, so that way I don't have to type them during the demo. So let's paste this in a chunk at a time, starting with the imports, and then the ML client, endpoint, and model. We can see a message that it's updating a local endpoint because, well, I've done this a bunch of times already. Next up, I'm going to choose the forbidden environment. We can see that Azure ML happily accepts this because all I've done was load a pointer to this curated environment, and that is absolutely fine. Now I'll copy the final block and paste in the code to update a deployment. Soon afterwards, we get a nasty looking error message and a required local artifacts not found error. This tells us that local endpoints only support local artifacts, that is, local models, local environments. If we want to run things ourselves, we're going to need to start with a public container image and build on top of it. And that's why I note that remote AML environments are a failure mode. Fortunately, some kind soul was nice enough to give me a working command, so let's comment out the wrong environment and uncomment this one. It requires a conda file, so let's take a look at conda.yaml. Eagle-eyed readers with sharp memories will notice that There's a lot more in here than what we had during the series where we did code first development with Azure ML. That's because the OpenMPI based container image that Microsoft provides is quite limited in what's pre-installed. So we're going to make sure we have a lot of libraries, including JobLib, NumPy, Pandas, scikit-learn, and plenty more. Granted, some of these libraries were specific to my efforts in getting an endpoint that Power BI can call, so we may not need all of these, but it doesn't hurt to have them. Alright, that's our conda file. Let's go back to the deployment script and copy this environment bit. Then I'll paste that into Windows Terminal so I don't forget to do it later. Now, we'll switch back to VS Code and take a look at the next file. I'm going to start with the failure2 file, so let's uncomment that line and comment out score model local. Now I'm going to jump into the failure mode 2 scoring script. This script looks fine. In fact, if I open up score model remote, we can see that it's exactly the same script that I use for remote scoring, except for one extra line. This script file will work perfectly well in Azure, but it will not run locally. The reason is on line 18. We are retrieving a model from the Azure ML model registry, and you cannot do that locally. Let's see how this turns out for us. Switching back to deployment.py, I'm going to copy lines 43 through 57 and run them again. So we can see that it runs some commands successfully, and it's pulling container image layers out of cache. For this new attempt, it would probably take about 3 to 4 minutes to download and prep everything the first time. But I don't have to wait for that. Oh, look at that though, there's an error. Down at the very bottom, we can see that the statement of local endpoint in failed state error. That's not very helpful on its own, but this is why we have the PowerShell tab open, so let's switch over to it. In PowerShell, I can run the command docker ps-a to get a history of any containers I've spun up. I have one here, and the next command will be docker logs, followed by the first few characters of the container ID. Doing this spits out any log information, so I could scroll up a bit to see where this log begins, and then see what Gunicorn spits out. Or G-Unicorn or Unicorn. Pick your poison with the name. The relevant bit of log is actually down near the bottom, right around this traceback. We can see in the JSON an error message that model Chicago parking tickets code first was not found in the cache. The local deployment is only allowed to look at local files, not connect out to your Azure ML model registry, so that's a no-go. Back in deployment.py, let's comment out that line and try the next scoring script, failure 3. I'm sure that'll work fine. Opening it up, we can see that I do not have a run function defined. Azure ML requires 2 functions for scoring scripts, init and run. Let's see what happens when I try to create this deployment. Let's switch back over to deployment.py and copy the test deployment block down to the end. Then I'll paste that into my Python REPL. We'll give it a few moments to start up the endpoint and try its hardest to succeed. Eventually though, it will fail, and we will want to investigate the problem. Over in PowerShell, let's once again kick off docker ps-a, and we can see the new container ID. I'll peruse the error message, and once again, down near the bottom, I can see the problem. User script does not have a run function defined. Well, it's about what I expected, so back to the drawing board. Let's comment out failure script 3 and move on to failure script 4. Opening up that Python file, I have everything in place that I need. An init function, a run function, I'm using a local model. The problem is actually in the run function itself. You see, on line 43, I'm using a command json.loads, which loads a string and converts it to a JSON object. But because I'm also using the inference schema package and defining data as a pandas data frame, I'll get an error when I try to perform inference. Let's see that in action. So to do so, I'm going to switch back to deployment.py, copy that last part of the script one more time. Then, in the Python REPL, I'll paste and I'll execute. This will start the process over again, except this time, I'm expecting success. I should not get a failure message here, And after a relatively short amount of time, we will have the endpoint going. We will see that it succeeded. The Python REPL gives us back a block of JSON, and I can switch over to PowerShell and run docker ps, which shows currently running containers. The fact that the container did not fail is a good sign for us. Now, how do I actually do anything with this container? Well, we can see 3 open ports. One of them maps to port 5001 inside the container, one goes to port 8883, and one goes to port 8888. Our scoring endpoint is actually the port mapped to 5001 internally. The external port number, that is, the number to the left of the arrow, is what I'll need to connect to on my local machine to reach port 5001 inside this container. So let's go over to Postman and give this a whirl. I have a Postman request all queued up, and I just need to switch the port number over. Once I've done that, let's click Send and see what we get. We get a generic error. Not very helpful. Fortunately, we can peruse the logs and see what's actually happening. Let's run docker logs and type in the first few characters of the container ID. Gunicorn logs post requests, whether they succeed or fail. And because we don't have any sort of try-catch logic in our run function, we get the full exception here. As we can see, the error is the JSON object must be string, bytes, or byte array, not data frame. What this is telling us is that JSON loads requires a string input, but we're sending in a pandas data frame, and so it's erroring out. That's not really what we want, so I'm going to stop this container and then remove it. I can stop the container with docker stop, and then remove it with docker rm. I want to remove the container so that it doesn't clog up my PSA command later, as this is a container I'll never want to restart. Okay, so now we go back to the drawing board. Back in deployment.py, I have one more script, score model local.py. If this doesn't work, well, I'm going to retire and be a beet farmer or something. If I open up that scoring script, we can see everything looks right. I'm using a local model file, my input data is feeding straight into the prediction, and so on. So let's go back to deployment.py, copy that last bit of deployment code, and try it one more time. It takes a little bit of time to start up the endpoint, but pretty soon we are going to see it succeed. And once it does succeed, we can switch back to PowerShell and see what the new ports are by running docker ps. I can see what the port is, so let's take that number and put it into the Postman command. By the way, you might have noticed that it went up by 3 ports. I've noticed that for each local deployment, the port numbers move up by 3. I'm not sure when they reset, but it's interesting to watch that number slowly grow as you rip out your hair one chunk at a time. Nonetheless, let's meet our fate and click that send button. And I get results back, which means no beet farming for me. That's good, as it means I'll save the beet farming for someone who actually knows how to do it. I hope you learned a bit about local deployments in this video. I also hope that covering these different failure scenarios was instructive, as I wanted to show you several of the most common reasons why local deployments may fail. I'm sure there are plenty of other potential causes, so this is by no means exhaustive. But if you do want to try it out on your own, grab the link to the repository in the description below and give it a go on your own machine. We'll have links and show notes in the description below, and until we see each other in the next video, take care.